Good morning everyone, Senan this side, and in this video we are going to solve this lemonade change problem. So you are standing at a lemonade stand and each lemonade costs $5. So customers are standing in a queue to buy from you and order one at a time in the order basically given by this list. Now customer will only buy one lemonade and pay with $5, $10 or $20 bill. Okay, so you must provide the correct change to each customer and the net transaction is that the customer pays is $5. So you do not have any change at hand first. So this is what we have to keep in mind. So we have to return true if we can process all the customers properly. Otherwise, we have to return false given the order of the queue. So you need to keep in mind that if you have a $5 bill given to you by the customer, you don't have to do anything, right? You can just keep that $5 and you do not have to return any change. In the case 2, if the customer pays you $10, you have to return him a single $5 bill. Otherwise, it's not possible, right? In the last case, if the customer gives you $20 bill, you need to return him $15. And to do that, you need to keep in mind that there are basically two ways you can give him $15. Either give him a single $10 bill or a single $5 bill, or you can just give him three $5 bills. Now what you have to do is try to be greedy. First of all, pay the customer back with the biggest possible bill that you have, because let's say you have if you pay a $20 bill with all the $5, and for the next $10 customer, you might not have some $5 to give that $10 customer back. So because this $10 can only be processed in giving the change back to a $20 customer, so what you do is you try to process the $10 bill first, and then if you are not able to give a single $10 and a $5, you try to give him three $5 bills. So that is the whole logic that I'm trying to do. So first of all, you keep track of these two variables, $5 and $10. These keep track of the number of bills you have of these two denominations. Since this $20 bill cannot be used to give as a change to any customer, I do not keep track of that as well. Okay, so I iterate over all the elements in the loop or in the array, and I say if I see a $5 bill, I just increment that 5 because I do not have to return him any change. Otherwise, if I see a $10 bill, I know I have to return him a $5 bill. So I increment my $10, the count of $10 by 1 because I received a $10 bill, but I need to return him a $5 bill. So if I have more than one bill of $5, 1 or equal to 1, I decrease that value by 1 and hypothetically give that $5 back to the customer. Otherwise, if I'm not able to do that, that means I do not have the proper amount of change till now. So in that case, I would just return false. In the second case, for the $20 bill customer, the last case, I try to give him one $10 coin or $10 bill and a $5 bill. If that is not possible, I go and check the remaining cases. But if I am able to give them, I'll just decrement the value by 1 for both the $5 and the $10 bill. Now in the next case, if I'm not able to do this, that means I either do not have a single $5 bill or a single $10 bill. So I try to give him three $5 bills, right? If I am able to give that, I am able to process that customer, right? So I just decrease the value of this $5 bills by 3. And if we do not execute this if or this else if, that means I'm not able to process this $20 bill customer. In that case, I return false. Now throughout this for loop, if at no point I return false, that means I'm able to process each and every customer. So in that case, I return true. And that is the whole video all about. It was straightforward, and the time complexity is big O of n, space complexity is constant. It's just a couple of if else statements, and yep, you're done. This is an easy problem. So yep, thanks for watching and bye.